Hi guys, today I'm going to go over finding measures involving diagonals of rectangles. Okay, so a rectangle is a parallelogram, okay, which means that all of those previous conditions that we talked about in the last topic, those 5 conditions are also true for rectangles. The one special aspect of a rectangle is that it has 4 right angles, okay? So we know that these corners of a rectangle equals 90 degrees. All right, so let's go ahead and do some of these and see what happens. Okay, so here is my first rectangle. I'm going to draw in what they tell me. Okay, so this is J, K, okay, and then this is N, this is M, and L. Okay, they tell me that Jn is 3x plus 7. Then they also tell me that Kn is 5x plus 1. The measure of angle JNM is 112. Okay. Find the value of x and the measure of NLK. Okay, so NLK is this one down here. So the first thing they asked me for is to figure out what the measure of x is. Okay, so in a rectangle, one of the special things is that the diagonals are equal. Okay, so if the diagonals are equal and they bisect each other, that means that this one is also equal to that one. Okay, and that's a special case in rectangles, that the diagonals are equal and they bisect each other. Okay, so what I can do is I can set these two equations equal to each other and solve for x. So I get 3x plus 7 equals 5x plus 1. Okay, I am going to move my 1 to this side, which gives me 8. I'm going to move my 3x to that side. I'm going to subtract 3x. This gives me 2x. Sorry, I subtracted 1. This should be a 6. Okay, and then I subtracted a 3, which gave me 2. So x equals 3. Okay, so x equals 3. Now they want us to figure out what the measure of NLK is. Okay, I'm going to erase this here. So if I know that this angle over here is 112, I have vertical angles, which means that this one over here is also 112. Okay, now because these two are equal here, I have an isosceles triangle. Okay, hopefully you can see that. So here's my isosceles triangle. In isosceles triangle, the angles below, okay, the two base angles are equal. Okay, so to figure out what those are, I know that all the angle measures in a triangle equal 180. I'm going to let this angle down here equal y. Okay, which means that this one over here must also equal y. Okay, so I know that adding all of those together will give me 180. So I have 112 plus y equals 180. Okay, 112 plus 2y, adding those together equals 180. Subtract 112, so I get 2y equals, so 768. 2y equals 68. Y equals, divide both sides by 2, I get 34. Okay, so I know that NLK is 34 degrees. Okay. All right, let's go ahead and I'm going to show you one more of these. So here's my rectangle. Okay, they tell me it's a rectangle. So I have this diagonal, that diagonal, E, A, B, C, and D. AE, so this length here is 4x plus 8. Okay, so A to E is 4x plus 8. B to E, so this length B to E is 6x minus 6. Okay, and then angle E, E, D, A is 59. Okay, find AC, so they want to know the entire length there. Okay, and they want to know angle BEC. Okay, the first thing they ask for is for AC. Okay, now there's an extra step that we have to do here compared to what we did in our last one. So we know that the diagonals are equal and that they bisect each other. Okay, so the diagonals are equal and they bisect each other. That means that this length here, this 4x plus 8, is equal to this length here, which is 6x plus 6. Okay, and we're going to solve for x. So I have 4x plus 8 equals 6x minus 6. Okay, I'm going to rearrange this. I'm going to minus 4x. And then I'm going to also add 6. Okay, so 8 plus 6 is 14. Those cancel. This equals 2x. And those are going to cancel. So then I divide by 2. All right, divide by 2. X equals 7. Okay, so I know x equals 7, but we need to figure out the length here. Okay, so to do that, I need to take x and I need to plug it back into the equation I have for the length of AE. Okay, so x equals 7. I have 4x plus 8 is what I'm going to plug it into. So I have 4 times 7 plus 8. 4 times 7 is 28, plus 8 is 36. Okay, so AE, that equals AE. Okay, AE is this length here. They didn't ask us for AE. They asked us for AC. Okay, AC is the entire length there. Okay, AC, we know that the diagonals bisect each other, which means that they divide them into two equal portions, equal segments. So this bottom one is also 36. So to find AC, we're just going to add those together or multiply 36 by 2. Okay, so 36 times 2 will give me the AC. So that is 2, carry 1, so 672. Okay, so 72 equals AC. Okay. Now the last thing they want me to find is BEC. So BEC is this one right there. Okay, I'm going to eliminate all this length stuff just so that we can focus on the angles now. Okay, we are trying to figure out what this angle over here is. That is a vertical angle, okay, which means that this side is also going to be whatever this side's going to be. We know that this bottom angle is 59, and that the diagonals bisect each other, so these two are equal. That means that this triangle down here is an isosceles triangle, okay? And in an isosceles triangle, the two bottom angles are equal. So if this one's 59, that one must also be 59. We know that the interior angles of a triangle all add up to 180, okay? So to solve for that missing angle, we take 180 and we're going to subtract 59 from it twice, okay? So this is 180 minus 59 gives me 121 minus 59 is 62. Okay, so this angle up here is 62. If this angle is 62, this angle over here must also be 62 because they are vertical angles. So BEC is 62 degrees. All right, let's go ahead and move on to the last one. I'm actually going to stop there. If you guys have any questions, just let me know.